Hey guys, welcome to another one-dimensional kinematics video, this time on the speed of sound. Okay. A bowling ball traveling with constant speed hits the pins at the end of a bowling lane 17.0 meters long. The bowler hears the sound of the ball hitting the pins 2.40 seconds after the ball is released from his hands. What is the speed of the ball? Okay, the speed of sound is 340 meters per second. Now, this is something that I haven't really said as much in previous videos, but I'm really going to start saying it now and from now on. And that is, in physics, in order to accurately understand the question and to make sure you don't make any little mistakes that could be easily avoided, is to always start the problem by drawing a picture. Always draw a picture of the scenario. Now, you don't need to be an artist to do it. In fact, the most simple sketch is the best one. Okay, it's just to give you an idea of the problem, how it looks, what's going on, and how to calculate. So we've got a bowling lane, 17 meters long. Okay, let's say that's your bowling pin there. See, I'm not an artist either. All right, you've got your ball. It's rolling. It tells you that the bowling lane is 17 meters long, so it has to travel this distance. But what you have to also see is that the sound is heard 2.40 seconds after the ball is released from his hands. Okay, so the time it takes to hear the sound is from the beginning until the end. Okay, so from start all the way to the end, that total time is 2.4 seconds. But you know that the sound isn't actually created until the ball hits the pin. Okay, so that's actually understanding part of the problem, in that sound is only going to travel in one direction. Okay, and that's from the pin when it's hit by the ball to where the person's standing. Okay, so let's get started. Okay, so time for sound to travel is what we're going to calculate first. Okay, so we start off with our original speed equals distance over time formula. Okay, d over t. Now, I've got a few different times here that I'm dealing with, right? I mean, I've got the total time here, and I just said that there's another time here that's the time, for the sound to actually travel. Okay, so I'm going to go ahead and call that time TS, okay? Time for sound. Okay, so if I go ahead and do that, well, I want to rearrange this for the time, because after all, that's what I'm looking for. Okay, so if you are not sure how to rearrange this equation for time, be sure to check out my previous video on approaching trains. Okay, but the idea is this. Okay, you've got a V on top, you've got a TS in the bottom. These two simply exchange places because one's being divided by, one's being multiplied. Okay, so you have TS equals D over V. Okay, now here's where you have to use your picture. Okay, this is the time for the sound to travel. So what distance does the sound travel? Okay, well, it's traveling when the ball strikes the pin, so it actually travels just one length of the bowling lane, which is 17 meters. Okay, so don't just blindly plug in numbers here. Make sure it actually makes sense according to the problem. Okay, so 17 meters, V would be how fast the sound is traveling. Okay, we're told that in the problem, the speed of sound is 340 meters per second. So you go ahead and plug that in. The units are matching up very nicely because we've got meters on the top, we've got meters on the bottom. So our final time is going to be quoted in terms of seconds. So 0.05 seconds. This is the time for the sound. Now, that is a lot smaller than 2.4 seconds, and it shouldn't surprise you. When anything makes a sound, you hear it almost instantly. And granted, it's not as fast as light, but it's pretty fast. Okay, so we found the time for the sound to travel. And remember, the original goal of the question is, what is the speed of the ball? Okay, so let's keep going. Okay, so speed of the ball, so I'll call it VBB for speed of bowling ball, is equal to the distance traveled by the bowling ball. Okay, so I'll just put that in here, over the time, right, that the bowling ball spends going down. Okay, so this is why we calculated TS, because we know that in total, it takes 2.4 seconds from when the ball leaves the person's hand for them to hear the sound. 2.4 seconds for that entire thing. Now just half of it, right? Just half of that time, here, let me move this down a little bit more. Just half of that time is attributed to 0.05 seconds. Therefore, the time it took the actual ball to go this way is going to be the difference between this and this. Okay, so 2.40 minus 0.05. Okay. So, I'll do that calculation on the side here. Time for the bowling ball is going to be equal to 2.40 seconds minus 0.05 seconds, which is 2.35 seconds. Okay. Now our D in this case, the time it takes for the bowling ball to reach the pins is the same distance that we had before that the sound needs to travel. Okay, that's just D, which turns out to be 17 meters. Okay, the time the bowling ball takes to reach the pin is 2.35 seconds. When you calculate that out, it gives you a speed of 7.234 meters per second. Okay. Now, just like always, we have to go back to the original problem and see the number of sig figs we're quoted to. Okay, so we've got 3 sig figs here in this 17.0. Okay, we've got another 3 sig figs here, 2.40. But here, for the speed of sound, we're only given 2 sig figs, right? Remember that last 0 is not certain. Okay, so it's just there just so we can fill in the rest of the number, but we don't actually know the number to that certainty. So the least accurate number we know is the speed of sound to 2 sig figs. Therefore, our final answer must also only have up to 2 sig figs. Okay. Okay, so when we round this, we're going to get the following value: 7.23 meters per second. Okay, so therefore, that's how long it takes, or that's the speed of the ball, okay, when it leaves the bowler's hand. Okay, so that's it for this video, guys. If you liked it, be sure to give that like button a click, subscribe to my channel so you can catch other videos on this channel, how to solve physics problems. If you think there's someone you know who can benefit from watching this, be sure to share it with them on Facebook or Twitter. Okay, thank you guys so much for watching, and I'll see you next time.